Let's start with some old stuff. Let's see if you guys remember this. You're going to see this question a lot throughout this semester. Given this, find the equation of the, in this case it'll be the tangent line. Somebody remind me, what does tangent line mean? The tangent line at this point A. What's tangent line mean? Yes? Okay, so it only hits it once, and what's the defining physical thing about that line? Like, same slope as this curve at that point. So this is sort of like a kind of a little morbid, but you know, you're on a roller coaster track, and this track falls away. For a split second, your coaster's going to keep going in the direction it was last going, and then of course gravity takes over, and everybody plummets and dies. But I watch too many horror movies. So the tangent line has got to have the same slope as the curve at that point, which is the defining problem. How to do that. That's the whole purpose of chapter 2, was to give us the tools we needed to be able to do that. Because algebra says you need 2 points, and we're like, we got 1 point. So there's got to be something we can do. So that's the tangent line. So we're going to see these problems that find the equation of the tangent line. So let's go back in time and remember how to just freaking find the equation of a line. Let's make sure we can all still do that. Of the line that goes through 1, -2, and is perpendicular to, oh yeah, 2x minus 5y equals 111. Do it. Don't celebrate too hard. You're not going to get this kind of easy question. This is just a review question. While you guys are doing it, I'm going to go ahead and give you the practice test. Just put this away for now, but just so you can have it. I'll have the answer key for this next time. Let me try to catch up with you guys. What 2 things do you need from this information to do what it wants you to do? The 2 things. What's the equation of a line? All right, I like it. What's the other one?
Y minus y1 equals n times x minus x1.
Yeah, this one's not hard to remember because slope is y2 minus y1 over x2 minus x1. It's just a reorganization of that slope idea. That's all this stupid thing is, right? Not too hard to remember. This one, I know a lot of us know how to get B. This idea shows up a couple times later this semester, so I kind of like to go back to this dude for this kind of problem. So let me ask again. What two things are in this equation that I need to figure out from what they tell me? What's this? That's a point, right? Do I have a point? Yes, sometimes I have a point, and I do right there. What's this? Slope. So if I get those two things, if I get a point, okay, I got the point. That's awesome. I got the point, 1, -2, check. Second thing I need is a slope. How do I get the slope from what they tell me? What does this have to do with this? Nothing. Nothing to do with each other. My line goes through this point, and it is perpendicular to this line. These have nothing to do with each other, necessarily. What do perpendicular lines do? What is true about their slopes?
They intersect at a 90-degree angle.
Sure. What's true about their slopes?
Are they opposite reciprocals?
Yeah, they're completely, totally different, right? Parallel lines have exactly the same slope. Perpendicular lines have totally opposite slopes. What I mean by that is not only opposite sign, but also reciprocated. So it's a negative reciprocal. So if I knew this guy's slope, then I know my slope. Do you see how the 111 doesn't mean shit? So I love to put a number here like square root of 11.87 or pi to the 14th power or something, because it doesn't mean shit to me. What's the only thing this is there for is to give me my slope. That's the only thing it's there for. So I only care about this guy's slope. How do I get this guy's slope? Yeah, solve for y. Because then I put it in that form, I can just look and see the slope, right? So I solve for y, add 5y, divide by 5, I get 2/5 x plus, who gives a shit? So what's that guy's slope? Which
Which one? The perpendicular line?
What's that guy's slope?
2/5.
Okay, so what's my slope?
Maybe 5.
Check. And now that I've got those two things, normally when I teach this back in Math 90, I'll say stuff like, now once you get these two things, you do the same damn thing. It's the SDT level. I don't care where this shit came from, I don't. You do the same thing once you get them. Plug them in. So what will it be? Y minus -2 equals -halves, 5/2 times x minus 1. And then you just clean this up. Y plus 2 equals -5/2. X plus 5/2, subtract 2, so subtract 4/2, I get -5/2 x plus 1/2. That's what it looks like. How do you check that?
Plug in the point.
Plug in 1, and you better get a -2 out. We do. -5/2 plus 1/2 is -4/2, is just -2, check. All right. That was, of course, unbelievably easy. Should have been, right? That's old shit. So what are we going to do now in calculus? What have we learned now that we still have to develop ways to get it, but it's going to be a part of this whole thing, is this way to get the slope. That's what's going to be different in this class, is we're going to develop more ways to get the slope. I don't have to only deal with lines. We're eventually going to be able to deal with whatever curve we get. We can figure out the slope anywhere. And then we just plug that number in. So calculus is a little more powerful. You can handle more situations, but the idea of this process doesn't change. It's just this step, I get the slope a different way. If I would have said parallel, I would have had a different slope here, right? I would have gotten the slope a different way. So now we're going to use calculus on this slope eventually. Okay, I like it. Okay. So I want to remind you of some basic ideas. Then we'll do computational ideas. So what do I mean by that? Well, let me show you kind of a new way to look at something we've done already. So on the slope of f of x at x equal to a. So we've sort of looked at this before, and I'll remind you of the way we did it before soon, but I want to kind of set up a slightly different look, just so you know what to expect when you see it in the book. So some point A, say here, I wanted a slope there. So one kind of different way to do it than we did before is to say, okay, so let's go a little bit away from there, and let's let x go to A. So another way to do what we did earlier was to add h. So we're just a little bit away, and then let h go to what? 0. So then I'm right at 1 point. I'm never at 1 point, but I'm approaching 1 point. That's why algebra works the whole way through, if I marry it with limits. There's a slightly different way to set this idea up, though, now. Limit as x goes to A. Let me let x go to A. And what's the slope between these 2 points? Well, what's this? This is going to be f of x. This is going to be f of A. What's the slope between those 2 points? What goes on top?
F of A minus f of x.
Yeah, and normally it's written like this. But it doesn't really matter, you're right, but we just put the x stuff first. Just because. So on the bottom it's got to be, so if f is x minus f of A, the bottom's got to be x minus A. This is equivalent to, because what does this accomplish? What does this do for me if I do this? What got me started here? What am I trying to find? I've got it, the phrase sitting up there. It finds the slope of f of x at A. That's what it does. I like it. And the way we did this before, this accomplishes the same thing as this would. These two accomplish the same thing. They find the slope of the function at a point. And the symbol we use for this most often is this symbol right there. Little prime. You can see that? Little prime dude. This means the slope of f. Right? In fact, let me be a little more specific on this example. This is the slope of f at A, specifically. So here's what an equivalent problem to the algebra problem we did earlier, here's what it would look like in calculus. And here's how you would do it. I love it. So it would say something like this. Let me take this away. So given f of x equal to, I don't know, find the equation of the tangent line to f of x at x equal to, doesn't matter, Jeff, 2, I like. So that's what the question would look like. This is an equivalent question as the one we did earlier. Find the equation in the line that is perpendicular to this and goes through that. Equivalent kind of question, but now I can ask a more sophisticated question because we have some more sophisticated abilities. So let's try to do this problem using this format, just to kind of get used to this format. What's A? What point am I interested in? 2 comma something. So A is 2. I want my x to approach 2. I'm interested in what's happening right at x equals 2. I like it. So A is 2. And then now we can just go to town. So let's try to write this. Try to write this using the function that I gave you. Try to write what that looks like. Just to help you out, what is f of 2? What's f of a? It's going to be f of 2. What's f of 2? 3. Just set up what that would look like now. So f prime at 2 equals, set this up. Never lose sight of the fact that I can still see algebra right there in front of my face. y2 minus y1 over x2 minus x1 is just algebra. It's obviously a little bit freakier because I'm letting these points get closer to something, but this doesn't really change. This is still the same old slope formula. As is the other one over there, really, but it's just a slightly different organization to the math over there. So what do you get? What goes on top? What is f of x? X squared minus 1. And then what's f of a? And then over top, I got x minus a, which is 2. Can you do anything with that? Why did I put a there? Gather. Is that indeterminate form? We know it pretty much has to be, but is it? How do you check that to see if it's indeterminate form? What do you do to see if it's in indeterminate form?
Denominator's going to 0.
True, but that's not good enough. That could be infinity. That's not indeterminate, that's an answer. Why is this indeterminate? Because it's going to 0 over 0. When I see that form, what do? Freak out. I'm eventually going to probably, since I have polynomials, I'm probably going to want to factor it. I'm going to use some algebraic method to get rid of the problem, to be able to determine the answer, just like you did on the quiz, hopefully. If you remembered how to factor cubes, right? You can use Pulp Fiction or not, I don't care. So I get limit, x goes to 2, x squared minus 4 over x minus 2. Can you factor the top? These cancel, so now what do you get for the limit as x goes to 2? 4. What the hell is that? 4 is what? What does 4 be? I should love it. Somebody went, the answer, man.
Slope.
What is it?
The slope.
Slopes. 4 is the slope. How do you know that? Because I freaking put that there for myself. And I know that this symbol means slope of this function. Just to make this really clear right now, all right, I'm going to hold off on that. Let's focus on this right now. So this is the slope at 4. So what I can actually call this is m. So I know m is 4. What's the point I'm dealing with? What's the point? Because remember, these are the two things I need. Slope, check. What's the point I'm dealing with? 2, 3. Because when you plug your 2 in, you got a 3 out. So that's the point I'm dealing with. And then you can do the whole y minus y1 business. If you really want to do the mx plus b, great. I'm always going to show you the other way in class, just to keep it alive in your brain. Because there is a section that they make it sound so horrible, but it's really just y minus y1 business written in calculus form. That's all it is. So how do I finish this out? I just y minus y1 equals m, so it's 1, and then I just plug stuff in. Y minus the y piece equals m times x minus the x piece. So the y equals 4x minus 8 plus 3. Kick ass. Wake this dude up. Try to, if you have your graphing calculator, plot this guy in y1 and plot this guy in y2. Do it up here. So if you do that, in the basic window, you get this. Where am I interested in on this picture? What kind of tells me where I want to look at? Where it intersects, but yeah, but the problem kind of tells me, I'm curious about the point 2,3. Everything's happening at 2,3. So you can see the point 2,3. Let me zoom in on that area a little bit. Do my favorite thing, a little zoom box. This is good old CSI enhance. Enhance. Let's see, how do I want to do this? Yeah, sure. Yeehaw. Alright, I like it. Alright, so there's the graph, and then here comes the tangent line. Maybe. Tangent line. Poor little dude. He's thinking hard. We'll let him keep going. But what's going to happen is, of course, here's the point. What is this? This is 2, 3. So whenever it finally, why are you having so much trouble, poor little dude? Should have the tangent line come in there and hit that sucker. Man, he's having a rough day. Let's see what's going on with you. Is there any extra weird shit in here? No? Alright, so what's your problem? There he goes. There he is. See, that's exactly, is that cool to guys? We constructed all the parts of this. This is the theoretical. This image matches the theoretically what should happen when I find the tangent line. It should hit that point on that function one time. And the one time thing is a little bit freaky because if it's going crazy, so one time really means, let me see if you guys are close to that point. And what does close mean? Could be like 0.0001 away. How close do I have to be here for that? I can be far away. Why? It's a really nice function. It's not going crazy. I like it. Maybe. It's always nice to see hard concrete work, hard concrete graph. There's the theory, right? You can't escape it. Okay, maybe. Okay, so anytime they ask you to find the slope, or you need to find the slope at a point, you could do it this way. Let's do the slope again the other way, just to kind of show you how it looks. What do I mean by the other way? Not the fx minus fa over x minus a, but the f of a plus h, that method. Let's see if we get the same answer. Our slope here was 4. So if I do it the other way you'll see is kind of gross, because to do the other way, it's not always gross, but sometimes it's gross. It's like totally gross. What's this? How do I do that piece? How do I do this piece? What is A again? I should put it in there. A was 2, right? Let's be more specific here. Well, how do I do this? How do I do f of 2 plus h? It's okay, just say it. It's easy.
Plug it in for x.
Plug it in, yeah. So plug a 2 plus h in for x. So that's f of it, 2 plus h. And f of 2 we figured out earlier was 3, right? Over h. Does this feel familiar? We did some of this before. So I have to FOIL this sucker out. Have you guys ever seen, real quick side note, very quick, this is going to come up later anyway. Let me just write some weird shit down and step back and see if anybody has a clue what the hell I'm freaking doing. Have you ever seen that before? Pascal's triangle. I love it. If you've never seen it before, it's not necessarily your fault. How did I construct this? 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 3 is 6. 3 plus 1 is 4. 1's on the outside. Right? What does it have to do with shit? Well, what's x plus 1 squared? X squared plus 2x plus 1. What are all the coefficients? 1, 2, 1. So what's x plus 1 cubed? X cubed plus 3x squared plus 3x plus 1. That is one immediate use for this. This is called the binomial theorem. Uses the numbers from Pascal's triangle to fill that in. This also has a connection to Fibonacci sequence, but I don't want to throw too much shit at you at once. Okay. This is going to become really freaking useful. Why does it not really matter here? It's just freaking squared. If it's free, who cares? But if this was a 5th power, I'd much rather go here and see all the coefficients and not have to actually write the damn thing out 5 times. And multiply and slowly go insane, right? No? You guys don't care? Okay. Oh, so if I do this, I'll get, let me put this in normal order. H squared plus 2h, 2h, 4h plus 4 minus 4. Is that cool? You guys see that? Why is this thing indeterminate form? Stupid h's, right? Stupid h's. And look what happens. The 4's go away. What happens to the h? Cancels, right? So you get limit. H goes to 0. H plus 4. And what is that limit? If you let h go to 0, what's h plus 4 go to?
4.
4, okay. You guys really don't want to. All right, you're getting paid to talk, bad boy. Talk for you, buddy. All right, shit. Same answer, right? That's the purpose of this. Same answer, a little bit more disgusting, to be honest, right? Yes?
So we use the H form when we have larger exponents?
This was, if you have larger exponents, like 7th power or something insane, neither method is nice. That's where this kind of thing comes in and says, I got you, don't worry. But really soon before we start doing that shit, we're going to learn a beautiful shortcut. So some of you guys, if you've ever had any calculus at all before, we are approaching the point where we're not going to use limits to get derivatives, to get slopes. We're not there yet. Don't get too excited. All right? Okay, maybe. All right. Let me do a little more, let's see. Oh, let me do this. All right. I'm trying to figure out which order I want to do things in. So let's do something, let's come back to theoretical. I want to bounce between concrete and theoretical. So everybody got this stuff? Oh, shit. It's on there too. Speak up. All right, let me do this. You got this? I don't know what he's got. So let me draw us a picture here. Let's see. I keep doing basically the same thing. Yeah, sure. This is interesting. I like this. This kind of problem, I normally don't put scale on there just so you don't worry about being precise where it doesn't really need to be precise. But I would give you a graph, and then I'll ask you, and so will the homework, can you graph what the slope would look like? So let me ask you this first question. Let me give us a couple of points here. Let's say A, help me out. Where are the slopes positive? Where's the slope positive here? What locations? Yeah, what's it look like? I try to get A to be this special little point here. What's happening at A? What's the slope at A? So if you're in the roller coaster, you're going up the hill. And then what happens? You start to go down the hill. But what happens right in between those two things? You are right at the top. Are you going up or down? It's zero slope. It's flat up there. Imagine doing the tangent line. Here's the tangent line here. That's positive. Tangent line, tangent line, tangent line. It kind of makes sense that if it's positive on one side and negative on the other side, right in the middle it's got to be zero. So it's flat at the top. It correlates to the max. Like, in fact, if that slope is zero, that is a place where a max or a min might be. It would happen here also, right? And there, of course, too. So where is the slope positive? Well, the slope is zero. Where's the slope zero? At A. Where's the slope positive? C. And where's the slope negative? Probably the other two. B, it's definitely negative because I'm going down. And D, I'm definitely going down. Where's the slope most negative? Looks to be at, amongst those four choices, at D. Looks to be at D. I love it. So you're going to get questions like this. Homework, quiz, test, handout today. I like it. So if I ask you to order those in from least to greatest slope, we basically already have that, right? It would be D, B. Those are the two negative ones. A is zero, and then C is positive. So D, B, A, C would be from smallest slope to largest slope. I like it. Most negative slope to most positive slope. Kick ass. I like it. I don't know if I want to do that yet, you guys. Yeah, not yet. Let's not do that yet. Okay. Here's one more thing I want to show you. If big ass f of x represents, let's say, the federal deficit, and big ass f prime of 2019, let's say that x is the year we're in, or the year you're interested in, right? So if you plug 2008 into this function, it would tell you what the deficit was in 2008. So if f prime of 2019 is greater than 0, what does that mean? Yeah, that it's increasing, that the federal deficit is currently increasing. The slope is positive. So currently the federal deficit is increasing now. That's what that would mean. So let's say that f of x is in billions, believe it or not. Let's say billion. Let's say, well, obviously it's trillions. I'm trying to make it smaller for us, but I can't. Let's say it's more specifically, what if f prime of 2019 was, I don't know, Jeff, 0.8. What units are on this slope? What units? What does f prime represent? Yeah, what f prime represents slope. Slope is change in y over change in x. So another way to write f prime of something. Do you guys remember, have you ever seen these symbols before? Delta y over delta x. Some teachers show that, some teachers don't. The delta means a bad airline. I mean, the delta means change in, big change in. So in calculus, what we use instead is D, that means infinitesimal change. So as X changes by something, F changes by a certain amount. Okay. Right. So those are the symbols for derivative in this class. This is symbols for derivative in calculus. You have the prime notation. The reason this is better notation is I can see the units now. What's F represent? Deficit in dollars, trillions of dollars, right? So this is trillions of dollars per, and what's X in? Years. Trillions of dollars per year. So if the derivative of the federal deficit right now in this year is 0.8, that means that I predict in a year it'll increase by $0.8 trillion. Let me see if you guys, how valid is the slope of this function? That's a weird question, but if I, look, there's a slope right at C. There's some slope, right, at C. The minute I move over a little bit, is it the same? No. So maybe right now I'm here for the federal deficit, so it's positive, it's 0.8, but if I move over a bit, now it's going down. So I can describe what this represents. It looks like after a year, the federal deficit would go up by 0.8 trillion. What will actually happen, I don't know, because how far is this thing valid? Just for that moment. Just for right now. That's the only time it's valid. If I take too big of a step, who knows what the slope's going to do after that. But I do love, later this semester, there will be my infamous stalactite, stalagmite problem, where I have you do some concrete shit and connect that with what the calculus predicts will happen. I want to make that connection. But right now, you just have to be able to interpret what this means. For a small step in time, it looks like the federal deficit will increase. Like it. And look, right here, if we're right there, if I take a little step in time, the federal deficit did go up. It does go up. But if I take another step, it's going to start to go down now. Because the slope is constantly changing. So I can't take that big of a step to make a prediction. That's why stock market, you don't go, all right, now I'll put a lot of money in, oh shit. Because you're making a prediction based on what's happening at that point. The minute it's not at that point anymore, who knows what's going to happen, right? That seems very basic, but that's what we're talking about. Okay, I think you have enough knowledge now.
What did you say the small d represents?
That's an infinitesimal change. And there's a huge controversy in the past about what symbols are better, or if infinitesimals actually exist, that kind of thing. But if you want to zoom in on a function, and you say, okay, what if I let x change by a little bit? What does y change by? Right? And when does this become, if I take too big of a step, delta means I've taken a large step. Large meaning anything bigger than infinitesimally small. So it could be like a step of 0.000003. That's huge. That's a huge step. We're not used to that being huge, but it won't. Is that the slope right at this point? This thing, is this the slope? No. If I let this get closer and closer, if I let this get delta x be smaller and smaller and smaller, it becomes more and more the real slope at the point. That's the whole thing about chapter 2. You guys with me? So if I let this become dx and dy, you can't even see that shit. Of course, the minute I do that, it's not really deep. But dx and dy, it's so freaking close to that point that it's basically the slope. That's the d's. That's the infinitesimal change. So think about the smallest positive number. Let me say that again. What is the smallest positive number? Do you understand what's happening? That's sort of like the inverse of infinity. Smallest positive number is keep on writing 0 forever, and at the end of forever, maybe put a 1. That's what infinitesimal, that's what the dx, dy means. Infinitesimal movement. Very tiny movement. Okay. So it's really interesting history about infinitesimals and who believed in them, stuff like that. Sort of like no-seeers. So I want you guys, the side that says 2-7, I want you to work on that side. In fact, let me try something different.